Hi guys, welcome back to the channel. So today we are going to be solving today's lead code question. So before diving into the question, turn on your DSA mode and then let's get started. Yeah, let's we are given a question like custom sort string, and then we are given two strings which are order and then yes, and then all the characters of order are unique, and then they were sorted in some custom order previously. And then we need to permute the characters of string such that they match the order in the where order was sorted. And then more specifically, if the character x occurs before y in the order, then x should occur y before in the permuted string. And then we need to return any permutation of a string such that it satisfies this property. Suppose let's take this particular example. Suppose let's say whenever we are sorting, we'll sort there is a Z and then A, B, C. Now, if we sort via same order, it will be A, B, C, and then there will be Z, because we are taking that A has a lexicographically smaller and then B is lexicographically larger. But here we are sorting via different case, that is custom sort, which is CBA, and then we are assuming that C is lexicographically smaller and then B is lexicographically larger, and then B is lexicographically smaller and then A is lexicographically larger. So that is the order for this sorting. And then one more thing is, if we see the constraints, the order length will be consisting of only A to Z, that will be from 1 to 26, and then S length can be 1 to 200. So if we do via 10 cube or 10 square also, it will be passed, but we'll go through the best optimal solution. So let us assume that we are given like only A, B, C, and then D till Z. It is given like this, the order of the string, and then we are given some random string. So now whenever we are sorting, we will sort based upon A will be less than B, B will be less than C, and then C will be less than D, and then C, like that. Suppose let's say we want to change the order, like BA. Whenever we have BA, B will be occurring before A. That will be the condition. Suppose let's say we have AA and then BB. Now whenever we sort, we will sort like S will be BB and then AA. So this will be the answer for this particular string, because we are given that B will be less than A. So whenever so the condition is we need to sort it. We need to sort based upon this order. This order means we need to take this order and then we need to feed this into this particular character, and then based upon whatever the value which is present in this particular order, we are going to sort based upon that order. Suppose let's take this particular example. Order is equal to B, C, A, F, G, and then S is equal to A, B, C, D. Now we want B to occur at the first place. That means we will assign some value to the B such that it will have the least value out of all the characters which are present. Suppose let's say we take from A to Z. Then at this particular C, we are going to assign C as 1. Why? Because it will have the least priority. Like it will be at the first starting itself, so we are assigning less value, and then we'll go to, yeah, this is given as B, so we'll keep, for B it will be 1, and then for C it will be 2, and then for A it will be 3, and then for F it will be C, D, E, F it will be 4, and then G it will be 5. Then after the string is done, the for other characters it is given as 0 0 0, but B should occur before C, and then C should occur before A, and then A should occur before F, and then F should occur before G. That means those values should be lesser. And then other characters doesn't have any number. So let us assign whatever we have left. This is 5. So let us assign this as 6, and then this as 7, and then this as 8, and then this as 9, and then this as 10, and then this as 11, and then again 12, like that. And then we'll be assigning till 26. All the all the numbers will be assigned to the specific characters, but for the first cases we'll be assigning based upon this particular order. And then we need to sort based upon whatever the numbers are present here. Suppose let's say b of, suppose we'll take a of b, like some number of b, then this will have lesser compared to any other characters. So b will be present at the first starting itself. So we can sort using different sorting techniques like bubble sort, insertion sort, selection sort, or merge sort. So we'll be looking at the merge sort, which will be like having the better approach. It will be solved in n log n. So let us see the solution. So the merge sort consists of two functions. Merge sort is nothing but, suppose let's say we have this particular string. We will break this string into two halves, which will be AB and then CD. Now AB will be, we will call the merge sort for this AB, and then CD like right. And then this particular string will be sorted, and then this particular string will be sorted, and then we are going to merge these sorted strings into one string, and then that will be our final output. So we'll be breaking the string into two halves, and then we'll call again merge sort on this, and then again merge sort on this. These two strings will be sorted, and then sorted strings will be merged back into the sorted string, and then we'll return back. So that will be the approach for this. So let us go through the function so that we can understand better. So first we'll be taking a, that will contain the number which is like order. So we'll be taking all the characters in the order, and we'll be assigning some number that will be I plus 1. So for first character which is present in the order will have one number, and then 2 3, and then again for the characters which have I equal to 0, then we are going to assign some next order, and then it will be incremented like we have seen previously, like this. And then after this we are going to sort based upon merge sort, and then we'll take left as 0, and then right as s dot size minus 1. And then as I had mentioned, like suppose let's say we have low and then high, thus that will represent that we need to sort this particular string from the low to high. Now let's say low is greater than high. That means this will be high and then this will be low. Suppose whenever they cross, that means it is not a valid. So we are going to return this particular, we are going to return it. And then we are going to take mid as low plus high plus 1 by 2. That means whenever we have low and then high, we'll be taking the middle value. And then we'll be calling the mid sort for one half of the string. And then again we'll call the mid sort on one half of the string, and then we are going to merge these two strings into one particular string that will be s. So it is kind of like we are breaking the we are kind of breaking two offs, and then again this particular string will break into two offs, and then like that. And then let's see the merge function. Merge function means we have one string which will be in sorted order, and then one more string which will be in sorted order, and then this particular string will range from low to mid, and then this will range from mid to I plus mid plus 1 to I. And then we'll store the characters which are present in the string from low to high in the temp, and then these are two strings from low to mid, and then mid plus 1 to high. Those are consider it as two strings. And then whenever we have like left is less than or equal to mid, and then left 2 is less than or equal to high, that means we are picking the left one and then left 2. whenever these are less than the right limit, then whenever we say temp a of temp left is less than temp uh, a of temp left, then we are left 2, then we are going to say s of left will store this particular character. Why? Because this is lesser. Suppose let's say this is lesser, then it is going to store this particular character into the string, and then again we'll increment this left 2 to left 2 plus plus, and then if we use this particular character, then we are going to increment left 1 plus 2 1 plus plus plus, and then this will store the index of s string, and then this will store left 1 and then left 2 for the temp string. This will not be, this is for our reference, and then this is for our storing the sorted order. And then let's say left 1 is less than or equal to mid. For this particular string it is lesser, but this is already exhausted, this particular string is exhausted. That means we are going to consider all the characters which are present at this time. So we are doing the same thing, and then again we are going to consider if let's say this left 2 is less than or equal to high, but this has been completed, so we need to consider all of this. So we will consider this, and then we'll at last we are going to return, and then that will be the answer. So if we come to the time and space complexity, the time complexity is going to be n log n. Why? Because we are doing via merge sort, and then the space complexity is going to be, yeah, big O of sort. It will be big O of sort. Yeah, that's all for this video. Thanks for watching the video.